Alrighty, hello, this is Marketia again. I'm back with another demo, this time with the Raspberry Pi Pico. Um, Kind of 4 parts getting started, us running stuff on the board, which I've been a little familiar with, but this is our first official time needing to do stuff on the board. It was broken down into 4 parts. Part 1 here is Hello World. I'll get into it in a bit. Just going to explain my setup a little bit because it's always a terrible setup that I have. I'm running here on a Windows computer. I'm going to go over the code here on GitHub, and I'm going to use my camera to show you the other machine, which is going to be my Mac running Linux here that is going to run the code on the Raspberry Pi. And this setup is going to work for all 4 parts that I have here. So I don't think I've used that actual LED. I think most part we're using the onboard LED. But this button is going to be used for part 4, which is debounce. We'll get into all that later. Some of them are going to be UART, so I will take the camera and show the UART console output here when necessary. I just have to do it this way because I can't run the board and recording equipment on this machine, on this Linux, at the same time. So we make do with what we have. So get you right back up here. We're going to start here with part 1 was Hello World. Pretty simple, infinite loop, prints hello world, not much to it. The only thing that's, I guess, much to it is using our cmake.txt, or cmake list, excuse me, where essentially this is going to allow us to run the UART and see the actual output of this code. All this stuff is our path. This is all relative to the Linux machine, not the Windows machine that we're looking at right now. But yeah, so I'm gonna pop over here, and I'm just gonna essentially get to that part 1 build directory. I'm going to take the board. I'm going to hold this little white button here is the boot select. I'm gonna hold that down while I plug in the micro USB to boot the board, so that once I can see its disk pop up here, I'm now going to be free to copy the UF2 file to the directory where I have the Pico. And then I will be able to go into my terminal, and I will be able to go to /dev serial on screen and see the UART output of Hello World running on loop. So that's pretty much all it is for part 1. Into the commands, just like I said, I cd here to part 1, copy the UF2 file to my directory, and then I go onto terminal here. I type screen dev serial to the UART connection, and we see that working. So that's simple, best way to start on the board that you pretty much can do. Best simple way, I should say. So we'll go here to part 2. That's part 1. Part 2, blink LED, exact same CMake file. Not much else to it. Just allows us to run on the board. There's some extra stuff here, just hopefully for future use that we're not using. We're not using a lot of these. I'm not using multi-core or anything like that. But into the code, I'm pretty sure it's the same thing we did for the research project. I think we were asked to do it in a class. I'm pretty sure this code was provided to us, just so that we can practice running on the board. So again, not much to it. Start blinking is really the function that runs, called here in the main, to blink the code. So I'm going to go over here. I'm going to do exactly the same thing. I'm going to cd, which is change directory, to that build folder in part 2. I'm going to grab my board again, boot select. I'm going to hold that down, plug my micro USB in again. I'm going to wait until the board pops up on the screen. I see it now, and then I'm just going to copy my UF2 file to the exact same directory I did before, and then that allows us to run the code. So we can see here, blinking LED. Not going to take you back to the Linux screen. It's all the same commands that I just ran. And yeah, we're using the onboard LED. I probably should have used this since I already had it set up and stuff, but I think I forgot to change it. So no big deal. It works. Now into part 3. We were asked CMake file is the same. This is the only script I think where the code wasn't provided, so this one gave me some trouble. It was Morse code on Raspberry Pi. Essentially, we were to use an LED, again, which case pin 25, I'm still using the onboard LED. We were to use an LED to essentially blink Morse code from a given string. So we define Morse code here. Dots and dashes is basically an entire dictionary mapping. It's not a map, but it is a mapping of the alphabet to whatever sequence it would be in Morse code. And since obviously we're not writing that in a serial console or anything, we are using delays to represent that. So the duration of a dot or a dash is going to be different. Dashes are going to have longer duration, so you're going to be able to see the string kind of come to form. We have these functions for dot and dash. Main function calls everything. The string we are passing is hello world. It is going to repeat infinitely. Bear with me. You will see a lot of blinking. It's not exactly obvious that it's hello world, but it is. So I'm going to hop back over here. I'm going to do the exact same thing. I'm going to head over to that part 3 directory, the build folder. I'm going to take my setup again. My Raspberry Pi. I'm going to hold that boot select down. I'm going to plug in the micro USB. I'm going to hold it down until I see the board pop up. And then I'm going to copy the file, the UF2 file, once again to the directory with the Pico. I'm going to hit enter, and then you can kind of see here that it is blinking. So there's no way for me to prove to you that it's hello world other than you can kind of note the different durations of the blinks. And note some would be dots, some would be dashes, and then there's a longer gap at the end, which is between each time it's doing the string, because it's on an infinite loop, so it's going hello world, hello world, hello world infinitely, and it's just gonna keep doing that until I unplug this thing. So you can see that works. Again, on the onboard LED, I'll give that an unplug. We're gonna reset, and then I believe the last thing we were asked to do is gonna be part 4, and that was just to represent debounce. So this code was also provided to us. 2 different scripts here. This is the header, also provided to us, but this essentially, the header just defines everything. Our button, our LED, our debounce. This is our debounce function, or our debounce script. We initialize everything. Essentially, what debounce is a delay to prevent the button from being sporadic when you press it. When we did the interrupt lab, we didn't do debounce, so we saw a lot of messages with each button press. So yeah, this was given to us, and then this is also given to us, the main function, which is just the main script essentially initializing all of this debounce CPP, and that's what we run. Same thing back over here. I'm going to CD to the part 4 build directory files, and if that's not clear, it's kind of pretty much didn't put it on GitHub, but it's on the local machine. Right back here, I'm going to do the same thing for the final time. Hold down my boot select, plug this in, wait for it to show up, copy the UF2 file. And this is, if I didn't mention before, this is going to be shown via UART. So I'm going to take you over to the serial console here to demonstrate that the button is being pressed. So I just copied the code. It's copying right now. And then I'm going to open my screen, which is my serial output. So take you over here, nice and blank, just opened the serial console. Let's try to get everything in the shot here. So this is our button, this is our ground, our serial console, so I hope this is a good shot. But essentially I'm going to press this button and we're going to see that it was detected. Button press detected, button press detected. You see we're not having that issue of sporadicness unless I'm like holding it in and doing the wiggle, which is multiple presses. But if I'm careful with it, one press is one press. And we see that that is a successful implementation of debounce. So that's pretty much it. I didn't have time to do the other extra credit parts. I was going to. I didn't. But that was all that was asked of us requirement-wise. So that's all 4 parts. Thanks for watching. I hope this one didn't end up being too long. I wasn't sure if I should have separated them or not. But yeah, that's it. Thanks. Bye-bye.